This is November 2010 modular paper, Unit 1, Statistics and Probability. Question 10 is estimating the mean. Estimating the mean. This has probably been on every paper I've ever seen, so make sure that you know how to do it. The table gives some information about the weights in kilograms of 50 suitcases at an airport check-in desk. There they are. So there were 16 cases between 0 to 10 kilograms. There were 18 cases between 10 and 15, 10 cases between 15 to 20, and 6 cases between 20 to 35. They want us to work out an estimate for the mean weight. Now the mean is the average, and it's the average where you add them up and divide by the number that you have. Obviously it works a little bit differently in a table. So in order to estimate the mean, you need to add 2 extra columns onto your table. You need one for the midpoint, because you use the midpoint as the estimate. That's where the estimate comes from. You need to find the midpoint, and then you need to do your midpoint multiplied by your frequency. So the midpoint of this is 0 to 10, which is 5. If the numbers are tricky, the quick way of working out what the midpoint is you add the 2 limits together, so 0 plus 10 is 10, and dividing it by 2, and 10 divided by 2 is 5. So for this one, we've got 10 to 15. I can add them together. 10 and 15 is 25, and half of that is 12.5. 15 and 20 is 35, half of 35 is 17.5. 20 to 35 is 55, halfway between is 27.5. So now I times frequency by the midpoint, and I've calculated these earlier to save time. So that's 80, that's 225, that's 175, that's 165. Now I can estimate the mean. To find the mean, you take the total of your FX column, which is this, divided by the total frequency. So I need to find the total of this column and this column. When I add those together, I get 645. And when I add these together, it gives me the 50 suitcases that they told me I had. So to calculate the mean, I can do 645 divided by 50, and that's going to end up giving me 12.9. And there's 4 marks there. The first mark is for correctly showing and using your midpoint. The second mark is for showing and using your FX column. Your third mark is for showing you applying that in the formula. And your answer mark is for the final answer. Now, I'm going to keep this page again because part B uses it. Passengers have to pay extra money for any suitcase that weighs more than 20 kilograms. 2 of the 50 suitcases are chosen at random. Work out the probability that both suitcases weigh more than 20 kilograms. Now, when I first read this, I was really tempted, because it says 2 out of 50, I was tempted to do something with 2 out of 50. But you don't. That's misleading. It's telling you that they're going to select 2 of the suitcases out of the 50 that are there. So yes, you are going to have a denominator of 50. Now, think about this logically. You've got 50 suitcases in front of you. What's the probability that when you pick one, it's going to be in the range of more than 20 kilograms? Our table shows that there were 6 suitcases more than 20 kilograms. So our probability of selecting one of those is 6 out of 50. So imagine now you've selected that suitcase, brilliant, and it's over 20 kilograms. What you are now left with is 49 suitcases, of which only 5 are over 20 kilograms. So I need to multiply those together because I want to know the probability of that happening and that happening. Multiplying fractions is the nice easy one where you go straight across. 6 times 5 is 30. 50 times 49 is 2,450. I can cancel this down by dividing both by 10, and that will leave me with 3 out of 245. So this was a 2-mark question. You get 1 mark for doing the individual probabilities, and you get the 2nd mark for getting the combined probability correct. Now question C wants you to draw a histogram for the information in the table. So that's this table again. Now a histogram is a bar chart, but instead of height determining the frequency, it's the area. So the area is important. And going up the side of any histogram, if you see a histogram question, always put the side label on, which is going to be not just frequency, but it's frequency density. Because you actually get a mark for correctly having the axis be in your frequency density. You have to calculate it first, but you will get a mark for it. Now, what you need to do here, to find the area of anything, you need 2 things. You need the width, and you need its height. So I'm going to look at my original table, and I'm going to make a note of the widths of all of these luggage boundaries. So the first one goes from 0 to 10. It's got a width of 10. The second one goes from 10 to 15, so it has a width of 5. The third one goes from 15 to 20, width of 5. The next one goes from 20 to 35, and it has a width of 15. So there's my widths. Another thing I know from the table is the frequency. And keep in mind that frequency, when you're on a histogram, is measured by the area. So I've got something that has a width of 10 and a frequency of 16. My calculation for this is 16 divided by 10 leaves me with a height of 1.6. This has a frequency of 18 divided by the width of 5 gives me 3.6. This has a frequency of 10 divided by a width of 5, which is 2. And the next one has a frequency of 6 divided by the width, which is 15, and that's going to give me 0.4. Now these heights are my frequency density. So I can go ahead and draw this on the graph now. I know it goes from 0 up to 3.6. So I'm going to go up to 4. And that's going to be 0, 1, 2, 3, 4. So now it's a matter of drawing my bars in, keeping in mind that the width is important. So my first width goes from 0 to 10. So I'll use a green pen, it's more visible. This goes from 0 to 10. So let's draw that bar in. It goes from 0 to 10 and it goes up to 1.6. So there's 1, 1.5, there's 1.6. You use a ruler and a pencil to draw a graph. That's not going to show on the camera, so I have to use pen. So there's my first bar, width of 10, height of 1.6. Now my second one, which has a width of 5, so it's going to be a narrow one, width of 5 and a height of 3.6. So there's 3, 3.5, there's 3.6. So let's draw this one in. Remember, it only goes across 5. My next bar also has a width of 5 and it goes up to 2, nice and easy there. And thirdly, it's got a width of 15, so it goes up to 35, and it's got a height of 0.4. So there's 0.1, 2, 3, there's 0.4. And there's my histogram. So you don't need to add this in, but if you were to calculate the area for this, you would have 1.6 multiplied by 10, which would give you a frequency of 16. This would have the frequency or the area of 18. That would be 10, and that would be 6, just like our table wanted. Now, the marks for this, it's a 3-mark question for the histogram. You get a working mark for using the frequency density and putting it on the graph as frequency density. You get the other 2 working marks for having all 4 bars correctly drawn. Question 11. A factory makes 600 laptops. Mrs. Green is responsible for checking these laptops. She's going to take a random sample of 80 of the laptops. Describe a method she could use to select the sample. Now, first thing I'm going to make you remember is that a random sample is when everything has an equal chance of being selected. The most basic random sample is pulling names out of a hat. Now, we can't do this here because we're talking about 600 laptops. So the first thing of any random sample when you've got a high number of things is going to be to number the laptops. And once you've numbered the laptops, you've got 2 options from there. You can either number the laptops, put the numbers in a hat and select from the hat. So pull in the numbers out of a hat. Or you can number the laptops and use a random number generator on the computer or on the calculator. Part B. Mrs. Green finds that 3 of the 80 laptops are faulty. Work out an estimate for how many of the 600 laptops are faulty. Now, an estimate means use previous information to predict on the scale that we're looking at. So if 3 out of 80 of the laptops were faulty, let's find out what that is proportionally as a decimal. 3 divided by 80 equals that 0.0375. I'm interested in that proportion of the full 600 laptops. So I've already got that on my calculator display. I'm not going to delete that. I'm just going to multiply it by the 600 laptops altogether. And that's going to give me 22.5. Now my marks from this come from M1 for showing that you multiply in the proportion by the number we have. And A1 comes from the answer. Now, you'd be right to question for this the fact that we're dealing with laptops and you can't get 0.5 of a laptop. As a result, the mark scheme also accepts 22 or 23 laptops, so it would allow you to round. This is a probability tree question. There are 10 socks in a drawer. 7 of the socks are brown, 3 of the socks are grey. Bevan takes at random 2 socks from the drawer at the same time. Complete the probability tree diagram. Now again, picture this. You've got Bevan standing by an open drawer where there are 10 socks. 7 of them are brown, 3 of them are grey. He's taking 2 socks at the same time. That means that the probability of the first sock and the probability of the second sock are going to be dependent because the number of socks in the drawer changes after he's taken the first sock. So to complete the probability tree diagram, we know that to start with, there were 10 socks in the drawer, 7 of which were brown, 3 of the 10 were grey. So let's imagine now, if we're going up this alley, that Bevan has taken a brown sock. That means that for the second sock to be brown, there's now only 6 brown socks left, and there's only 9 socks in the drawer altogether. For this one, Bevan selected a brown sock to start, so that means all of our grey socks are still in there. So all 3 grey socks are in there, but there are only 9 in total. And if you look at this, Bevan, in this scenario, selected a grey sock first. That means all 7 of our brown socks are still in the drawer, but there's only 9 in total. And only 2 of his grey socks are in there, out of 9 in total. So, part B wants you to work out the probability that Bevan takes 2 socks of the same colour. So I either want to find the probability of brown and brown, or I'd be happy with grey and grey. So in order to find the probability of brown and brown, I'm interested in this happening and then that happening. So it's that probability and that probability. So 7, 10 and 6 in 9. Now the fact that this is an AND scenario means I have to multiply them. Now let's look at what else I'd be happy with. I'd be happy with grey and grey. So that's those 2. So that's going to be 3 over 10 and 2 over 9. So they're the 2 situations I'd be happy in. Now if I'd be happy there, or I'd also be happy if that happened, I need to add them together. This is because I'm increasing the probability that I'm going to come out happy. So multiplying fractions, as we said before, is the nice easy one where you go straight across. So 7 6s are 42, 10 9s are 90. Add 3 times 2, which is 6, and 10 times 9 is 90. Denominators are the same, so when you add them, it stays out of 90, and you end up with 42 plus 6, which is 48. So the probability of me getting 2 socks of the same colour is 48 over 90. The mark scheme for this question, you get a method mark for identifying that probability. You then get the second method mark for getting these all correct, okay, because they're conditional. For part B, you get the first mark for showing that you've identified those 2 events happening and adding them together, and your second mark is for having the correct answer. Question 13 is about sampling and proportions, I suppose. So the table below shows the population of each of 3 villages: Ashley, Brigby and Urton. Mr. Akhtar carries out a survey of the people living in these 3 villages. He uses a sample stratified by village population. There are 50 people from Brigby in his sample. Straight away I'm going to go up to Brigby, and I don't know the significance yet, but I'm going to say that there are 50 people to go with Brigby. Work out the number of people from Urton in his sample. Okay, now first of all, stratified means that the number selected is proportional and representative. So that's what stratified means. So the fact that there are 50 people from Brigby in his sample means that we're dealing with a proportion of 50 out of 370. So when he stratified his sample, it ended up telling him he needed 50 people from the 370 that lived in Brigby. Now, I want to keep that proportion, and I want to find that proportion of Urton. And Urton was 127 people. So I want to find 50 divided by 370, which gives us that number, 0.135. And I want to multiply that by the 127 people in Urton. And that's going to give me 17.162 with recurring dots above the 1 and the 2. Now, this is the type of question where I'm dealing with a number of people. I cannot get 0.1 of a person, and if I could get 0.1 of a person, I'm pretty sure I wouldn't want them. So what I need to do is round it to a whole number of people. So he needs 17 people. The mark schemes, it's only a 2-mark question. You get the first mark for working out the proportion of people needed, and then you get the second mark for working out the actual number of people needed. Now I want you to add up all the marks that you got, and because the total paper is out of 60, I happen to get 60 out of 60. Not that I'm bragging, but you write it as a fraction, 60 out of 60. Then on your calculator, you do whatever you had out of or divided by whatever you had. So in my case, I had 60 divided by 60 equals, and then I times that by 100 to get it to a percentage. So I just happened to get 100%. No big deal.